Hello friends, this video is going to be on how to work with inverse functions. So probably the most important thing to remember about an inverse function is if the original function has an ordered pair on it of AB, then the inverse, which is written with a power of -1, would have the ordered pair of BA. In other words, the x and y values switch places. So when you're given a graph and you're asked to graph its inverse, all you're going to do is you're going to go to the original graph and you're going to look at some points that are on the original graph. For instance, this point right here is the point -1, 2, 3, 4, 5, is the point -6, -2. And this point here is the point -4, -1. And this point is the point -2, 0. And this is the point 0, 1. And this is the point 2, 2. And this is point 4, 3. And this is point 6, 4. So if those are on the function f of x, then the function, the inverse function, which we would name f to the -1st power x, the inverse of f of x would be -2, -6, and -1, -4, 0, -2, 1, 0, 2, 2, 3, 4, 4, 6. And so if we were to plot those points, if we were to plot -2, -6, -2, 1, 2, it would be here. And -1, 4 would be here. And 0, -2 here. And 1, 0 here. 2, 2 here. 3, 4 here. And 4, 6 here. And then if we were to graph that, or connect those points, then this line is the inverse. So this would be called, well, that's a little thick. This would be called the inverse of x, and this line would be called f of x. And so the green line is the inverse of the pink line, and something that you're going to be asked every day in Canvas is what is the line of symmetry, or what is the fold line? And the fold line is the line y equals x. So if we were to graph the line y equals x, well, you know what, it'd probably just be better if I didn't try to dot it. If we were to graph the line y equals x, if we fold the graph on that orange line, then the pink line would land on top of the green line. The green line would then be the inverse of the pink line. So basically what you do is you switch the x's and the y's and graph. Okay? A couple things to note. The pink line is a function. And the green line is also a function. Remember, we learned back in September that to be a function, it has to pass the vertical line test. So if we put a vertical line test and we run it across the pink line, you'll notice the blue line only intersects the pink line once. That makes it a function. Also true that the blue line only crosses the green line once, making the green line a function. So it is a function. We'll just hold on to that because we'll use that again later. All right, so right now the quadratic that is graphed is a function, and we'll name it f of x, and we'll list some points, some easy points. This point right here is the point -2, 0. The vertex is the point 1, -9. The other x-intercept is the point 4, 0. And if I wanted one other nice point, perhaps this point right here would be considered a nice point. That's 5, 7. And if 5, 7 is a nice point, then perhaps this point over here would be another nice one, which would be -3, 7. Yep. So that's the function f of x. So if I want points that are on the function f of -x, I want to graph the point 7, -3. And I want to graph the point 0, -2. And I want to graph the point -9, 1. And I want to graph the point 0, 4. And I want to graph the point 7, 5. So 7, -3 is here. And 0, -2 is here. And -9, 1 is here. And 0, 4 is here. And 7, 5 is here. And so then if I try to graph that, now this is not going to be pretty. If I try to graph that, it's going to be this shape. That's not too bad. Let's see, can we extend that out here? Squeeze this in? No, we cannot. Pretty close. We'll go with that. So that is the inverse of f of x. So, does it pass the vertical line test? Great question. The function does. The pink one does. So the pink one is a function, which we knew because it's named a quadratic function. So does the other one pass the vertical line test? Does the green one? And the answer to that is no, because if we go this, the blue line hits the green curve twice. The blue line hits the green curve twice. The blue line hits the green curve twice. It fails the vertical line test. Okay? So, kind of interesting. The original function, the pink one, maybe I should make it pink, so. This is the original function. If the original function passes the vertical line test, so if the original function, the pink one, passes the vertical line test, it is a function. If the pink function fails a horizontal line test, see how the pink function fails a horizontal line test? If it fails a horizontal line test, its inverse would fail the vertical line test. So if you don't have a graph of the, inverse, you can take the graph of the actual function and run a horizontal test. And if it fails the horizontal test, then its inverse is not a function. And so we can test that with this picture up here also. So remember, we're going to look the original, the function was the pink function, correct? So the pink function passes the horizontal, the vertical line test. If we turn the line to be a horizontal line, the pink line passes the horizontal test. So if the pink line passes the horizontal test, then the green line is a function. It's just kind of a cute thing there. Okay, get rid of that now because I think that's my last graph. Okay. Oh, and I forgot to put in what line is it symmetric over? It is symmetric or foldable on the line y equals x. And if you'll notice, what's really cool about that, there you go. There's the line y equals x. So it's foldable on the line y equals x. And what's kind of cool about that is this point right here and this point right here on both graphs. That's just kind of cool. So, alrighty. There's nothing relevant there. It's just that the xy's are the same number in both functions. Okay, so what are we going to do? Awesome. So what we're going to do most often, algebraically, is we're going to find the inverse. So we are going to, first of all, rewrite this problem so it says y equals 5x. Because our brains like y equals better than f of x equals. Okay? Then we are going to rewrite the problem. And we are going to rewrite the problem by taking the x and taking the y and switching their places. Not the terms, just the letters. So we're going to write x is equal to 5y. And then we're going to solve for y. We're going to solve for y by dividing by 5, which would tell us that x divided by 5 is equal to y. And then you would write the inverse of f of x is equal to x over 5. And that is our answer. So, because when we did the graph, we switched the x's and the y's. What was x became y, what was y became x. When we do it algebraically without a graph, we are going to switch the x and the y's. So step one, actually, step one is to write it as y equals, because no one likes f of x. So we're going to write this as y equals x minus 7. Then step 2 is to switch x and y. So step 2 is to take this y and write it as an x, and take this x and write it as a y. Step 3 then is to solve for y. So if I want to get y alone, I am going to add 7 to both sides. And that would give me x plus 7 equals y. And then step 4 is to write it as a function. Write as inverse function. So then we're just going to take what we have and we're going to write it as the inverse of f of x is equal to x plus 7. And what you will put in Canvas is x plus 7. Okay. And if you want to see if that's true, you could go to, let's see if we can do it quickly. You could go to Desmos. And in Desmos, we could put the original question, which was y equaled, and what was the original question? Y equaled x minus 7. Y equaled x minus 7. There's that line. And in our stuff, he was pink. Well, we'll leave him red. And then the inverse came out to be y equaled x minus 7. Nope, x plus 7, my bad. What's happening? Y equals x minus 7. Switch them. Add 7. Yes, that's correct. Sorry, I got lost. And then if you're like, well, that doesn't really look like an inverse. Remember, oh, what am I doing? The inverse is supposed to cross over the line. Y equals x. And if you folded it across the green line, then the blue line would land on the red line. So those lines are inverses of each other. Okay. Wish my colors were the same as on my... Okay, here we go. So this one. So let's remember our steps. These are our steps. Okay. So, step 1, write as y equals. So we're going to write y equals the fraction x minus 8 divided by 3. Switch x and y. So x equals y divided by y minus 8 divided by 3. Solve for y. Why did I write? My brain keeps getting in my way. Okay. So then we're going to solve. So to solve, we would multiply this side by 3, and we would multiply this side by 3 to get these to cancel. So we would have 3x equals y minus 8. And then we would add 8 to both sides. And we would have 3x plus 8 equals y. And then we would write it as an inverse function. So the inverse of f of x would be 3x plus 8. And so that would be the answer. And if you're like, well, I'm not sure that's correct, then, well, hi. Then you could go back to the original picture, x, and you could say, make this, it was x minus 8, and let's see, I would need a parenthesis there, and a parenthesis here, and I would need to divide this by 3. So it would be that line, and my answer was, what was my answer? My inverse was 3x plus 8. So if I put in 3x plus 8, 3x plus 8, there it is. And it's folded on the green line, so it is the inverse. So if you folded the graph on the green line, the blue line would land on top of the red one. Maybe that'll help you see it. The red line lands on top of the green line when you fold it on the orange line. So kind of cool. I like inverses. They're kind of fun. Alrighty, so here we go. I'll put that in there. So according to our steps, should we bring those down with this so we can see them? According to our steps, we are going to, first of all, write this as y equals negative 2/5 x plus 1. Then we're going to, so that's that one, done. Now we're going to switch x and y. So that would be x equals negative 2/5 y plus 1, done. Now we want to get y isolated. So if we want to get y isolated, to get this by itself, the first thing that has to go is the 1. So we move the 1, and we have x minus 1 is equal to the negative 2/5 y. Then if we're going to get y alone, the next thing we're going to do is we are going to multiply by negative 5. Because if we multiply by negative 5, this negative 5 cancels this negative 5. And that gives me negative 5, parentheses, x minus 1 equals 2y. And then to get y by itself, we would divide by 2. And we would have negative 5 halves x minus 1 equals y. And then if we're going to write it as an inverse, we would say the inverse of f of x would be equal to negative, negative 5 parentheses x minus 1 divided by 2. And we could write it in that way. Now, if you're a person who doesn't like the way I did that, that's fine. I did that because of my math struggles. If you don't like that, then you could definitely have done it this way. We'll do an alternate way. So we had y equals negative 2/5 x plus 1. We would still go minus 1. Whoops, forgot to change my x's and y's. This is x, and this is y. Subtract 1. That's going to give me x minus 1 is equal to negative 2/5 y. We could have multiplied by negative 5 halves. We could have multiplied by negative 5 halves. And that would have given us negative 5 halves of x minus 1 is equal to y. So the inverse of f of x is negative 5 halves x minus 1. Either way, you get the exact same thing. It doesn't matter. They are the same answer. You can put either one of them in Canvas, and it will be fine. It just kind of depends how your brain sees it. Let's look at it. Negative 2/5 x plus 1. So if we go to Desmos, negative 2/5 x plus 1. It was a fraction. Negative 2/5 x plus 1. And we changed it to negative 5 halves. Whoops, I forgot the division symbol. Negative 5 halves x, was it minus 1? Minus 1. And yeah, there it is. And if you fold on the orange line, the green line would land on the red line. So, cool, cool. All right, that is it for the video. So remember these 4 steps. That you're going to write it as y equals, you're going to switch x and y, you're going to solve for y, you're going to write the inverse. The other thing you want to make sure you put in your notes is that maybe the better, if the function has the ordered pair AB, then the inverse function will have the ordered pair BA. And don't call them opposites. They're not opposites. They switched places. If they were opposites, their signs would change, not their order. Okay, that is it, my friends. Have a great day.